Hey everybody, I'm Michael Hall.
And I'm Robert Wolf, and we are your co-hosts for Innovation Coffee, brought to you by ARM, where the developers meet to talk about the latest and greatest things happening in and around the ARM developer ecosystem. And today, Michael, we are going to be meeting with two amazing individuals from Cosmonic. This is Liam Randall and Bailey Hayes, CEO and CTO in that order. To talk about Cosmonic and WebAssembly on ARM. This is going to be a great episode. We look forward to teaching you all as much as we can, talking to these folks as much as we can about this topic and their company Cosmonic. So it should be a lot of fun. But before we dive into this episode, Michael, I think we usually like to go through what happened last week, right? And you are, I think, now our resident expert in last week's happenings.
I'm the look guy. Okay, so last week we had a couple of people on to talk about Rust on ARM. So we had David Brown and Wilfred, whose last name I don't remember right now, but he works for ARM. David works for Linaro, and they were talking about Rust on ARM and some of the cool things that they were doing. They were each building their own custom keyboards using Rust embedded on these ARM devices to build these really cool keyboards. They both had something completely different. Like, it didn't look like a normal keyboard. Just some cool hacking projects. But we also got to learn a lot about the production state of embedded Rust and how it can be used in IoT devices. So that was a really cool episode. People can go back and watch that on our YouTube channel.
Is really nice. And by the way, it's a Chavot. I believe that's how you say, yeah, Wilfred Chavot. And he's from ARM with David Brown from Linaro. So that was a really cool episode. And in fact, it was nice to touch base with David Brown, one of our ARM ambassadors, in fact. And I used to work with him back when I worked at Linaro 4+ years ago. And it's just always nice to catch up with old friends and colleagues. What do you think, Michael? Should we kickstart this episode, or should we remind people first about liking and subscribing?
We should definitely remind people about liking and subscribing, because that helps us and it helps them.
Yeah, so make sure that if you do enjoy this episode, don't forget to like and subscribe. And of course, if you have any questions throughout the time that we are all having our wonderful conversations, feel free to post them in the YouTube chat, and we will get to them as soon as we possibly can. And of course, if you are watching this on demand, the comments are still there, so feel free to post something in the comments, and we will do our best to address those as soon as we can as well. So I think it's time. Let's bring in our guests. We have Bailey Hayes, CTO from Cosmonic, and Liam Randall, CEO of Cosmonic. Hello, how you two doing?
Mike, Rob.
Doing great.
Yeah, thanks for having us on the show. We're excited to be here.
Excellent. I love to see the energy here. You guys, we were meeting in the green room earlier. It looks like we're gonna have a fun time talking about WebAssembly and Cosmonic. But first, I'd like to get to know you two. Could you maybe provide us with a little bit of what we call the origin story segment of Innovation Coffee? And maybe we start with you, Bailey. Is that okay?
Absolutely, yeah. So my name is Bailey Hayes. I am the WASI co-chair within the W3C's community group for building out the standards for WebAssembly. I'm also the technical steering committee director on the Bytecode Alliance Foundation, as well as CTO on Cosmonic. But the way that I got started, my origin story for this, is that when I was fresh out of college, one of my first projects was trying to figure out how I take all this legacy C++ code and find a way to run it in this new technology at the time called HTML5. So the time around here was 2012. And I stumbled on this project called ASM.js. And ASM.js is really the precursor to WebAssembly. And I got to work with an amazing dude called Alon Zakai, and he was working at Mozilla. And he created basically the greatest hack of all time, ASM.js, which is, what if we find a way to take C++, transpile it to JavaScript, and have it be just this tiny subset of JavaScript that's incredibly fast. And what that basically created was, hey, we don't actually have to come up with a bunch of changes to our browser to make this extremely efficient, right? We're taking advantage of known paths within the JavaScript compiler in browsers. But the superpower, the reason why it's the greatest hack of all time, is that it proved that everybody needs this, everybody wants it, and you can't stop it, right? Because JavaScript's everywhere, and if it's just targeting JavaScript, that means it can run. So what that caused is us to all come together across the industry and design WebAssembly starting in 2015.
So you were at the pinnacle of it. You were at the beginning of WebAssembly.
I was, young hacker, just solving problems. And I've gotten to really grow my career starting from that origin. Yeah.
That's awesome. I remember when HTML5 came out as well. I think it was like Apple who were one of the first people to kind of adopt this in terms of the media frameworks, right? And everyone was kind of like trying to figure out that transition period. I could be wrong. I was just kind of getting into my college time at that point.
You're making me feel old. I remember when HTML4 came out.
Oof.
I mean, who doesn't remember the ASM.js, Doom running in a browser day? I mean, that was probably like, we're probably still on Slashdot then instead of Reddit, or just making the transition over. But I mean, we all remember that day. It was like, this site best runs in Firefox, and sure enough, it took right off. And who knew that what that little kernel of vision would have grown into? But I think it's not just a moment in tech, but it's really become the movement in tech, the future of computing. And I think that's what we're really going to talk about next.
Very, very cool. So Bailey, nice to meet you. Thank you so much for your origin story. And what about you, Liam? We're going to get to know you.
Yeah, sure. I think my origin story is not quite as pure as Bailey's. My career started working my way into security. As an undergrad, there was no DevOps. This was in the 90s. I just started writing network software to deploy software, and we just called it enterprise administration when I was getting my CS degree. By way of a somewhat circuitous route, I ended up writing protocol analyzers and working on a project called Bro. It's now referred to as Zeek, and it was a phenomenal journey. We started a company that's still around, and I built and helped to build a huge open source community. And ultimately, while it was a really incredible and important mission when you're working on security, it was very defeating because it felt so often like we were really just hacking away at the leaves of evil instead of solving it at its root. And if you're not familiar with large-scale network monitoring, essentially you put network taps down and you start looking for bad things. And every network that we instrumented, whether it was a government network or it was a corporate network, and these are some of the biggest and most recognizable names you can possibly imagine, at scales where we hit the 64-bit, the birthday problem on 64-digit integers in a day, to talk about the scale of traffic we were instrumenting. It was just the same problem everywhere. And as containers and Kubernetes emerged, I really believed that we weren't going to solve the problem in security, that we needed to move upstream. So I left the industry and focused upstream. I started the very first Kubernetes company in 2014, an absolute rocket ship, 5 million revenue in the first year, and ended up, instead of raising money, selling the company to one of our customers, which was Capital One. There, I ended up as VP of Innovation, which is a misleading title because at a place with 12,000 engineers, I was surrounded by innovative people. And I owned the OSPO, the Open Source Program Office, and I really learned that we hadn't raised the abstraction high enough, that while the golden paths and platforms that we were building made the problem better with abstractions on abstractions, we still had so much work to do. And by providing these golden templates, we kind of compounded the problem, because while developers were secure on day one, when we gave them all their boxes checked with a Java Spring Boot template, they were then shackled with these decisions and were forced to maintain it on an app-by-app basis. And we were crushed by problems like Log4j or Bash bug and all the rework that needed to happen. So in innovation, we started this search for bigger abstraction, and that led us right to WebAssembly and what we now refer to as the WebAssembly component model. And I loved Capital One. Financial services is such a central mission where you can really find meaning when you're working, helping people in the heart of their financial lives. And ultimately, it meant more to me to take a chance to help build another big community and to have a chance to work with innovators like Bailey Hayes and the rest of this great ecosystem. And so a few years ago, we launched a CNCF WASM Cloud, which is now the biggest, one of the fastest growing frameworks inside the CNCF. We're getting ready to go incubating and hit 1.0. And we also launched Cosmonic, which is a company that builds tooling and infrastructure to help companies adopt WebAssembly and WebAssembly platforms at scale.
Yeah, I'm actually kind of. I thank you so much, Liam. It's funny because I'm recognizing our conversation, or I'm rekindling our conversation that we had at KubeCon,
Right.
and you just reminded me. As soon as you mentioned CNCF, I'm like, this is the Liam that we talked to before the showroom floor opened at KubeCon.
Yeah.
Cool. And let me ask you real quick. By the way, thank you so much for the intro. How did KubeCon fare for you? Did you have a good time?
Oh, it was great. I mean, I love community. I've been a serial entrepreneur. I mean, since I was a kid. The very first thing I sold, one of my old bosses got me one as a little, like, a rubber band gun. It was like when I was 6, working in a fair market. I've got one over here on my entrepreneurial bookshelf next to me. A community is always just so central to building the best products. And it's not a question of, is open source better software? I mean, if you're still having that argument, you just haven't been following along. The diversity that community brings to problem solving, to use cases, to testing, to innovation. It's not a question of, are we going to use open source software? The problem we're really trying to solve is the high cost of free software. And it's not the high cost, obviously, to adopt. It's the high cost to operate, the high cost to maintain. That's the problem space that isn't apparent when people start building and adopting things like Kubernetes and open source platforms. However, I think we can get these costs under control with technologies like WebAssembly that let us encapsulate them into more secure runtimes, to componentize them, and to bring them into scale. So Kubernetes, for me, is always a big drink of water. It's meeting with people that already believe all the things I believe in. It's inspiring, it's hopeful, and it's just a great time to find out what people are excited about. And, from a thematic point of view, while places like Capital One have been building, we're building platforms a little bit ahead of the curve. I think platform engineering is one of the dominant themes of 2024, and I think we're hitting the market at exactly the right time.
Well said, Liam. Well said.
Yeah.
Thank you.
All right. Well, why don't we just jump right into this? So I'm a web guy. I know web technologies. I now am a hardware guy, so I'm starting to get into ARM assembly stuff. But the web doesn't have a CPU or a instruction set. So what is WebAssembly then?
Yeah, there's this joke that we say in the WebAssembly community that WebAssembly is neither web nor assembly. It's an assembly-like language, but it doesn't just run in the web. It is a portable instruction set that you can target from high-level languages. So I can write code in Rust or Go or Python, and I can compile that code to WebAssembly, and I get a .wasm out, and I can take that .wasm and run it anywhere there's a WebAssembly runtime. And so that it obviously is the browsers, but it's also in runtimes like WasmTime that back Fastly and Cosmonic, so that you're able to run WebAssembly basically from the edge to the cloud.
I like that. Awesome.
I think the easiest way to think of it is I like to think of WebAssembly as the world's smallest virtual machine. If we think about it as a virtual machine for application code, it sounds and looks and smells a little bit like Java, except it's not particularly tailored to a particular language. And from an idea point of view, the idea is very similar to a lot of ideas that have come before. The idea that we could originally bring a secure way to bring other languages and pack them up in a portable way, like Silverlight or Flash or even Java, has been around for a while. What really distinguishes WebAssembly, though, are a few other details beyond its technical definition. WebAssembly, when we talked about open source, I think we started in a great place because WebAssembly is owned by the community. In fact, it's a W3C standard. And so when we think about what does that mean to people that are considering adopting WebAssembly, it means that it's yours and it's already included in all the great platforms and products like the 3 major browser engines that you could be building on top of. There's implementations that are open source that you can embed into your products or adopt seamlessly on the server side. And there's even great runtimes that package up these core engines like CNCF Wasm Cloud that you can adopt and make a part of great developer experiences, such as building them into your platforms for platform engineering or into your internal developer platforms or IDPs. So that's super powerful, and that's really what the industry needed. Whereas the monopolistic vendors have previously tried to enforce or put their own proprietary visions on the cloud. WebAssembly is unique because those same vendors have come together and they have joined in the standards process, and they've committed deeply and are deploying WebAssembly into their products and into their cloud platforms because they recognize that open is a better way and that standards are a great place for us to compete and collaborate on.
Awesome. Very cool. So hopefully everyone watching now has a better idea about what WebAssembly is. I'd like to kind of now pivot into Cosmonic. I know you got the shirt on. This is about WebAssembly with Cosmonic. And this is, I think, a great time to talk about, who is Cosmonic? What does Cosmonic do? And, after observing your website, by the way, very polished, straight to the point, great website. Maybe we could kind of answer this question for the community and talk about Cosmonic for a sec.
Yeah, Bailey, maybe I'll get started. We've talked a little bit about where companies are today, and the sad reality is that most companies find themselves today shackled to engineering decisions that were made 10 or 20 years ago. That the original engineering decisions that drove a selection of languages and frameworks still continue to tightly couple them to not only platforms, but oftentimes even CPUs that leave them stuck into place. And it's hard for them to have that sort of velocity that helps them to meet the needs of what their businesses need now. What their businesses need now is very important because technology has always responded to what the business needs. The business needs to move faster. The business needs to run globally. The business needs to bifurcate based on regulatory domain, and it needs to bring the applications as close to the users as possible. And that's very hard to do when you are building with frameworks and templates and tools that were designed 20 or 30 years ago. So what Cosmonic's core strategy is built around is an open core. And that open core resides right in the CNCF, in CNCF WASM Cloud. What we've done is we've positioned CNCF WASM Cloud as the universal application template. It's a pluggable template that leverages WebAssembly components in order to solve the common application requirements that you would typically get with a framework like Spring Boot or with another framework in Go or in Python. If you're not that familiar with WebAssembly components are reusable and pluggable across language frameworks. So whereas you might normally start with a framework like Spring Boot, so you have things like key value and a web server and metrics and tracing, we can use WebAssembly components to satisfy those requirements on a language agnostic way. And while WASM Cloud can get you going very quickly, what Cosmonic does is then become the universal deployment target. It lets you take those applications and then run them across any cloud or edge, including your own. So Cosmonic provides tooling and integrations, not only for things like Kubernetes, but also agents that let you run it across Mac, Linux, Windows, and we're working on integrations that take you deeper into edges that you're familiar with now.
Awesome. And let's make sure that we share that link to Cosmonic so people can go see that. And we'll, of course, include that in the description below if you're watching on demand. Cool. Michael, why don't you give them the next question here? We have so many questions and your answers are so great. I have a feeling we're not going to get through all of them. So Michael, you're up.
Yeah. So I want to touch on something that Bailey mentioned a little bit earlier. So people don't write WebAssembly, right? They write code in another language. You mentioned Rust and Python. How do you get from those to that WebAssembly file that you can run?
Yeah, so There are WebAssembly modules, and another word that Liam mentioned earlier is WebAssembly components. And that is basically this new standard that we've been working on for the past maybe 3 years, starting with WASI, where we designed a monolithic ABI that says, hey, you want to run this language like Python outside of the web or in the web, but Python needs a lot of things that typical webby projects don't have access to, like sockets. A lot of the different pieces of Python to be able to compile require sockets. And so within WASI, which was originally coined the WebAssembly System Interfaces, I think it's a lot easier to think about as WebAssembly standardized interfaces, but interfaces that allow us to target things that let us run it anywhere, both in the web and outside of it. And so with a piece like WASI and an SDK that lets you basically have all the things that you need to compile that language, you target it by writing your normal Python code, but then use the right tools that know how to do that target natively. Now, many different libraries and upstream language STLs, like in Wrestling, it knows how to target WebAssembly directly. And it also knows how to target this new version of WASI that supports the component model. And when I describe the difference between WebAssembly modules and WebAssembly components, I would say that a WebAssembly module is basically a bunch of numbers in a trench code. It's like literally I-32s as far as the eye can see. And it doesn't know things about high-level types or higher-level interfaces. So it doesn't know what a string is. It doesn't know what a record is. All of those types of things, all of those get translated into numbers. But with WebAssembly components, we're able to raise that level of abstraction so that we can have these basically modular interfaces that are defined with high-level types like strings and structs. Our structs in this world are called records. And you can also have things like enums and variants. So by being able to work with WebAssembly components, we're also able to continue moving these open standards forward a lot faster because we're able to define things independent of one monolithic ABI is what we originally came up with in 2019 for WASI Preview 1. And so by having this, we've also designed something that lets us reach this like language interoperability nirvana, where not only do I allow this to be a portable compilation target that many high-level languages can support, I also now know, because they're components, they are composable, I can now combine these other different components, WebAssembly.wasms, to each other and be able to interrupt between the two. So without any like CGO magic and a lot of friction and a lot of pain with what we currently do, like there's no JNI or like special types of buses across. It's the component model itself. The standard understands how to take these different types, compile to different languages, and have them interopt. And what that means is that we have a lot of common tooling now within the Bytecode Alliance, where we make it really easy for you to take languages written in other, like let's say we write in Go. We now have a lot of what you would take to bind interfaces to high-level types and strings, but you're able to write just normal Go code and talk to something else that perhaps was written in Rust. And what we're aiming for is for everything to still feel native, right? I want the executable target to fade away. Like, how weird is it that we are talking about, like, when was the last time we talked about an .so or a .exe? That's kind of weird, right? But it is a really exciting technology because it lets you do a lot of amazing things. And once you get it into a .wasm, it's so portable that you can run the exact same .wasm in a web, on the server as a web worker, or even in a database as a user-defined function. And that level of portability and security that you get by hitting this target, it's something that we've never seen before in any other tech.
That is awesome. And you know, this, I think, brings me into a question. It's a good little segue here, because you did talk about the Bytecode Alliance. I'm interested in knowing what types of tools makes developers' life easier, more streamlined when working with WebAssembly and or Cosmonic. So maybe you could kind of highlight some of those. Also, this is a two-parter. I would also like to know a little bit more about what languages are the best supported at this time in terms of working with WebAssembly, because you've already thrown out Python, Rust, and so maybe are there more? You know, which are the best supported? What can developers look forward to in their WASM journey?
Yeah, there's gradients. I'm going to start with the second question first, because what it comes down to is first you need to be able to support WebAssembly modules. If you can support modules, you can support components. We can take a module and adapt it to be a component without ever having to recompile the developer's code. We take that .wasm, produce a .wasm that has effectively metadata about the high-level types that are used. But for being able to support your language being able to compile to a .wasm, usually it's a mix of you have a language that either it has strict types, and you have this fully defined type system. You can do ahead of time compilation. And so that's why for many languages that were supported first, Rust, C, C++, those were all, your initial languages that targeted WebAssembly. It's a lot easier to do that. Now there's this new wave that's happened over the past couple of years, and that's for languages that have an interpreter. And so with Python, you'll see that we were able to compile the C Python interpreter to WebAssembly. And then that allows us to take Python and run it, right? You can see how that works. For JavaScript, we also have support now. And so there are actually a couple different runtimes and tools that you can use. You can choose between having a really low memory footprint, or you can choose something that has like a really fast runtime. So inside the Bytecode Alliance, we have a tool called JCO, JCO. That's the JavaScript component tooling. And what it does is it bundles in effectively the SpiderMonkey runtime to be able to run JavaScript code as WebAssembly code. And so we're able to do basically a compilation pass that way. And all of this to say, when you look at the map of languages, something like Rust that doesn't require a runtime is very easy to add WebAssembly support. And then there's this gradient. And the things that have come first tend to have better ergonomics today because we had a lot of time to build out tooling and improve DevX around it. But that's all coming online because it's been one of the, I would say, an explosion over the past year of adding WebAssembly support across many different languages. I want to give a shout out to VMware here, where they even have languages like PHP, which I never thought I was going to see in WebAssembly working. Yes, so they've done a lot of forefront work for PHP. Another example is C Ruby. It uses basically the same techniques that we found would work for Python, where you compile in C Ruby to WASM, and now you have WebAssembly support for that language. Now, there were two-parters, so I know I hit the language part, but what about the other part? Where are the tools?
Yeah, what tools?
Okay. So the Bytecode Alliance, it's a nonprofit software organization where we're aiming to build secure foundations for WebAssembly. So basically, not just tools, but also runtimes. So within the Bytecode Alliance, we have WASMtime and WAMR, the WebAssembly micro runtime. And so WASMtime is really beloved for its amazing security model, all the fuzzing we add. We put in a lot of work to make sure that your WebAssembly runtime provides a secure sandbox, and it's incredibly fast. We've got two different types of compilers in there, an ahead-of-time compiler called CraneLift, and another one called Winch, which is a baseline compiler from Shopify. Made that contribution from Saul Cabrera. And inside WAMR, it's really amazing for being able to run on embedded and IoT devices. It's this itty-bitty thing, hence the name, the WebAssembly micro runtime. And, WASMtime's written in Rust, WAMR is written in C, and they're both pretty interesting projects that have a super healthy community. But within the Bytecode Alliance, we also have a number of different tools. So I mentioned JCO already. That makes it really easy for you to take JavaScript code and compile it to WASM. There's another tool called Componentize Py. It lets you componentize your Python code into WASM. There are other pieces for a little bit of ergonomics for C#. Actually, a lot of the languages, they all fall into this one project called WIT Bindgen. And WIT is our WebAssembly interface types. That's a high-level specification of types. It's an IDL for me to be able to say, actually, I want to pass around strings and functions and structs and all that kind of stuff. With WIT Bindgen, it generates the language bindings for me to talk across all of these different languages. And so inside that one project, there are many other languages that are supported overall. So a lot of folks know about WIT Bindgen, they call it. And then I guess the last big tool that I'll give a shout out, but there's so many more, like VS Code language extensions, that's in there too. But the last one, WASM tools. inside WASM tools, it's a mono repo of a bunch of tools that people love to use. At the beginning of the call, we said nobody actually really writes WebAssembly, and I do want to say that there are some people that write what's called WAT. That's the WebAssembly textual format. So it's a human readable version of what is basically like a stack machine. That's what it looks like to write WAT. I don't know many people who write it, except for a lot of the folks in the Bytecode Alliance. When we're writing tests, we do a lot in WAT so that we know that we've got the right test. But on stage, Oscar Spencer actually wrote some WAT that compiled Python to WebAssembly, and that was just mind-blowing. So there are those people. Just want to make sure we shout for that. And to be able to do a lot of that, that's inside the WASM Tools project.
I think if I could summarize a little bit of the broad overview that Bailey just shared for some of the people listening at home, is that WebAssembly is an incredibly fast-moving and growing space that has so much breadth that there's a lot of specialized tools that are coming online. And when I think about good starting points and tools, what we've tried to do in our ecosystem, which is CNCF WASM Cloud, is really try to start with a WebAssembly experience. And our focus that Bailey leads is in taking these tools and wrapping them up so that developers can focus on a single purpose, which is leveraging the power of WebAssembly without necessarily having to understand or track all of this complex iteration and tooling underneath. We try to do the hard work to pull together the right versions of the tools, to do the work to integrate them together, and to wrap them up so that developers can focus on writing their business logic, and the platform can focus on delivering those common capabilities. And that's really been our vision for WASM Cloud since day one. We launched that vision even before the WebAssembly component model had been finalized. And I think we've really executed well on that, and have now, I think, taken somewhat of a leadership position in that space, in that as those standards are released, we're typically one of the first to release support for them, as we've continued to adopt and embrace them across the ecosystem. And given Bailey's sort of dual role leading both ecosystems, contributing to leadership in both ecosystems. These are huge ecosystems at both sides. WASM Cloud over the last year grew from 70 contributors to something like 440. So it was a pretty massive growth in adoption.
Awesome. So cool. So I actually have some questions about what you just talked about, Liam, in just a minute, but I do want to address some questions in the community, and Michael, I think, is going to call on these.
We've actually got quite a few questions in the community, so let's jump into them. Peter Ng, one of our ARM ambassadors, wants to know about running WASM applications on a desktop and with a user interface. Is there some abstraction like JWT from Java that will let you write like a desktop windowed application that can run on different platforms?
Yeah, so there's a lot here. I have used Towery, which is a Rust framework for writing desktop apps, and I've embedded WASM Cloud in that before. And that's a great way to run WebAssembly inside. What I see a lot of people do is use tools like, Electron, to run desktop apps, right? And Electron, because it's based on Node.js, has a WebAssembly runtime inside it. And so what we're seeing is this huge evolution and growth in the space of having frameworks like Leptos and other web frameworks that are Rust-based now, enabling us to write in other languages that the developers prefer to work in, be able to compile that to WebAssembly, and then, yes, have this wonderful desktop experience. I also want to give a shout that, Cosmonic is focused on giving you that app platform, and we are one of the few that really do love our Windows users, and we have a host that runs really well on Windows, Linux, Mac, ARM, all the places, and that's because of underneath we're heavily invested inside WASM Time, and WASM Time is the runtime that is kind of that magic sauce that lets you run basically anywhere server-side WASM. So I love Node.js; it's great, but it's kind of chunky if we're being honest, and WASM Time does not have that problem.
All right. Peter had a second part to that question, and I'm actually going to combine it with one of mine. We've talked to a lot of developers from Java, from Rust, from .NET about how they're optimizing their runtimes by using specific ARM instructions. And Peter wants to know, for WASM, can it take advantage of those lower level instructions and abstractions? Can it talk to things like CUDA or machine learning accelerators like NPUs?
Absolutely. So there's two parts to this. There's the first part, which is the compiler and your WebAssembly runtime. I keep hyping WASM time. I am obviously biased, but within WASM time, we do have a number of different pieces that take advantage of hardware optimization. And so I actually just want to say ARM is actually part of the Bytecode Alliance. And so they're also part of our story of improving a number of these different tools to target and optimize WebAssembly code. And so there are some cases and benchmarks where actually taking native code, compiling that to WASM outperforms native. Now, that's a scale, right? Those are for very specific micro benchmarks. Usually you're going to see a slowdown of like maybe 2x the speed of native code versus something like JavaScript or Python. When they're running, they're usually around 60 times slower. So you get something that's very near native already with WebAssembly. And the more that we collaborate with folks like ARM, we're going to get something that is just right there equivalent. And the other side of this, the other part where we get hardware optimization is from WASI. So WASI is sort of like this API that lets me tell the host, hey, I have this interface that people want to use. They want to call the web GPU. So how do I expose that to my WebAssembly module in a safe and secure way when my WebAssembly module, again, is a bunch of numbers in a trench code? It actually itself, without a WebAssembly runtime, doesn't have access to networking or the file system or GPU. But through WASI, the runtime can expose that to that WebAssembly module. And so we have things for doing neural networks with WASI-NN. We've got sockets and all of that. So all of those pieces also can get fully optimized for whatever hardware it's running on.
I think that this is actually one of the real superpowers of both WebAssembly and the WebAssembly component model. So when we think about, what WASI represents is, this is the ABI. And when we were earlier talking about the ABI that, containers target, for example, we're really thinking about POSIX and, the 530 system calls that we find in Linux and what they represent. This is critical for composing WebAssembly applications because from a security boundary, when we compose a WebAssembly component, you only include those WASI APIs that are necessary for that module. And what that means is that it's share nothing. If the APIs aren't necessary, they're not even available. And from an enterprise or developer point of view, they're extendable. So if you have some component or some world, let's imagine that you build video games for a minute and you want to extend WASI to include basic principles for game development. You have some KV store, you have HTTP, you have a blob store for memory, and you might want to have some native elements like objects or video game or characters or worlds or other high-level mechanisms. These things are infinitely extendable at runtime and then pluggable via implementation. So this really gives us a place and a world and a time that are really enable, I think, a broad vision for software engineering and software development. And it's amazing as we've started to build applications using different languages to see them using the same Lego blocks underneath the hood. It's just awesome to see, it was happening before when we're ultimately compiling down, but when you can see TinyGo and Python and other languages using the same core WASI functions and know that you can just hot swap them or update them at runtime as opposed to compile time, it just solves so many of the daunting security and operational challenges that have just plagued developers and enterprises since the dawn of computing. I think we're really at, poised on the precipice of a new age of computing here.
So this kind of brings in, I want to address some more of the community questions. We will get to your questions in just a second, but this does bring in one of my questions, at least the way I interpreted it a bit. And it goes back to Cosmonic and, again, looking at the website, looking at the things you all are offering in terms of services, what your product does. I kind of feel I've always been kind of a believer that the world is somewhat headed towards a low code, no code type of developer space. Would Cosmonic kind of fit into this movement in some way, providing developers with a more low code, no code interface or tool to kind of get their product to market quicker, right? I mean, one of the biggest failures for startups is being outcompeted. And so, is Cosmonic kind of sitting in this space, helping developers get there?
Rob, I think so, although we shy away from the word because unfortunately most low code platforms are very high boilerplate. And it's the problem is not, there's two parts of the problem here. There's, the time to innovation, which is the problem that we're really trying to solve here. But that is very tightly coupled with the maintenance and the operation problem. There was a study that was on stage at reInvent, splashed up from Deloitte, that mentioned that enterprise developers spend 80% of their time on operations and maintenance. And maybe in your org, that's 60 or 70%, but it's still a very high percentage of time when you're looking at the amount of time to patch and repush containers through GitOps pipelines in order to keep them up to date, or to troubleshoot the latest version of Kubernetes or the operational platform that you happen to be using at time. And those problems are all very tightly coupled with each other. When we think about what is after this Home Depot model of computing that most developers are still stuck in today, where you push your cart down the aisle and you configure a VPC in a network, and this very static world, is this world that we see being adopted at places like Cosmonic or the edge scalers like Fastly and Cloudflare, where you're provided with high-level constructs like KV, like SQL, like HTTP, and developers deliver their business logic. The platform provides updates at runtime and handles scaling. And when we think about other, major innovations in tech, when we think about epics of computing, there's always been these massive sort of decouplings of ideas or abstractions. From an abstraction idea, think about the sort of a vision that an idea like MapReduce ushered in. It decoupled the idea of scale and compute over space, or Snowflake decoupling storage and compute. And WebAssembly's fast startup speed and size let us decompose a similar problem. The problem that enterprises have wanting to run everywhere mean that WebAssembly lets us solve the cold start problem. It means we can deploy it everywhere, but we don't have to run it everywhere. We can run it per invocation. So WebAssembly solves this problem in a really powerful way because developers and companies can pay for what they use at runtime. It also means because we're starting it, we can always start it with the latest and most up-to-date dependencies. So it's a really powerful model when we start to think about it from what do developers and what enterprises care about, and what does it mean.
Great answer. That's awesome. Michael,
I want to ask a couple of questions that came from our community, actually, from two different people, from Pipalia and follow up from Peter, asking, can WebAssembly, could it be the end of the C++ era? Or, as Peter said, might it be more the end of like the runtimes and the JVMs like .NET and from Java?
I think that you get the best of both worlds. In that if you have code that is in .NET, let's say, their WebAssembly support is amazing. It's one of the best supported languages and frameworks out there. So if your company, however, is able to have onboard this new team, and that team is a bunch of gophers and they don't know .NET, well, it's no longer this case where you have to like stop shop, have them upskill into whatever decisions you made a decade ago, learn that thing, and then come on board. Instead, they can interrupt and work together. And so I think that what we're going to see over the next 5 years is us eliminating these silos, these language and framework silos that we've spent the past several decades building up. Those are going to fade away because I can easily interrupt with somebody else just because they gave me an API. But it's not like I made them do all the work of providing me a REST API and I had to pay all the costs in milliseconds to be able to call their API. Instead, I'm calling their API in nanoseconds because all of this is able to run inside the exact same process.
Awesome. Want to go on to the next one?
Yeah, Pipoli also asked, is WebAssembly, does it have any use cases in embedded systems? And Bailey, I think you mentioned a very small WASM runtime already for that kind of use case, right?
Yes, Whammer is one of the runtimes that a lot of folks reach for embedded use cases. WASM time also has a pretty small compilation version. You can do a tiny WASM time, but yeah, Whammer, there's been a few really good talks. I recommend watching them. Chris Woods from Siemens talked about some of their embedded use cases. Sony Midakura gave a talk at WASMCon talking about some of their IoT style use cases, and then also Bosch. So we're going to see WebAssembly in planes, trains, and dishwashers probably over the next year.
Awesome.
You know, and I would just add on to that it's not only are there great use cases, I would say that pretty much everybody on this call and that's watching this podcast is already using it for those use cases. When we think about notable use cases, it's often quipped that the future is already here. It's just not evenly distributed. Despite WebAssembly being relatively new to many people on the call, it's been under development and adoption for quite some time. There are some vast use cases when we think about Amazon Prime Video, possibly the most distributed application on the planet, with support that they mentioned in a blog for over 8,000 unique type of edge devices. They're using one of the smaller WebAssembly edge runtimes to deliver their code. When we think about hyperscaler edges like Fastly or Cloudflare, behind the scenes, WebAssembly yet again. So I think that when you consider the sort of unique role that companies like Cloudflare and Fastly play in just being, infrastructure for the internet, WebAssembly is already embedded in your day-to-day life. Even companies like Shopify, talk famously and are huge contributors to WebAssembly as standards through the release of tooling, I think thought leadership, code contributions, and so forth throughout the entire ecosystem. So this is a path we certainly see with a lot of adoption throughout CNCF, and I think is continuing to grow as the technology becomes more and more mature, and as that language support has continued to improve across the ecosystem.
So I've noticed throughout this episode that you both have been talking about WASM and like CNCF WASM Cloud. You keep saying we, not they. What is your role, both as individuals and Cosmonic as a company, within this WASM community?
I would say that we play a large leadership role. We wear different hats though between Liam and I. So I definitely take it from the let's define a roadmap. Let's figure out what the key pain points are. What do we have to solve in Q1, and let's knock that out. So some of the work streams that I've been playing around in, it includes getting components working for .NET and having a really sharp Go native idiomatic Go story. And I'm a maintainer inside WASM Cloud. And so we're, driving towards 1.0 so that we can give folks the guarantees and stability that they really need to be able to adopt WebAssembly within their orgs. And from a leadership standpoint, Liam is actually behind running, most of the program committees for a lot of the major WebAssembly conferences. And he also brings together that vision and explains it in a way that I don't, I jump in, I'm like, well, the compiler does. Whereas Liam really, crisply defines what business leaders need. And the kinds of problems that they're running into. And he's pulled together what feels like the entire industry into doing this new wave of computing?
Well, look, Bailey, I think that we're just two examples of many of the incredible personalities that compose the broader WebAssembly ecosystem, and I think the two of us, are representative of the community that you do find in WebAssembly. It is, for the large part, very collaborative, and even years ago when we did the keynote for the CNCF, one of the KubeCons, maybe 2019 or 2000, it was Ralph Scolacci and we wanted to come up with a really representative tagline, and we came up with Better Together. Because when we thought about the fundamental and inherent risks to WebAssembly, it was really not working together. And even among the WebAssembly startups, when you look at there's Cosmonic, there's Fermion, and many others, Dialibso, and other folks across the ecosystem, there's a high level of collaboration and coordination and support. I think we've all embraced that the rising tide lifts all boats. And unlike many other epics of tech that came before this, think about like Docker and containers, the kind of a previous epic of tech. This is an epic of tech where the shared artifact is open source. Virtualization was primarily driven, we think about the epics of tech, we had, full PCs. Virtualization was driven initially by VMware. The initial dawn of cloud was driven by AWS and then other providers. Containers were initially driven by Docker, and through a somewhat controversial list of mechanics, were somewhat forced open. And then the orchestration standard was thankfully donated by Google to the CNCF. So Kubernetes was I think the first great representative example, but not quite an industry standard in the way that HTML, CSS, and JavaScript are. So the original founders of the WebAssembly movement, when we look at Lynn and Till and Luke, who are still very largely involved in the Bytecode Alliance and were the creators there, had a broader vision of being even more open than that, and creating a formal standards body that followed the same kind of process that led to the democratic adoption that we find in the web in HTML, CSS, and JavaScript. And it's hard to argue with this sort of wave of compatibility that has been ushered in thanks to that foresight and universal collaboration. And I think that's what markedly distinguishes WebAssembly. And look, I was one of the two creators of Wasm Cloud, but I think that everybody that joins the Slack channel, it's part theirs. So I'm a very big tent person, and it is, it was always going to go to the CNCF as far as I was concerned. So it's not mine for sure. It is the royal ours, or the big we, and it's something that we can all work together on to make better. Because there does need to be these open and common paths. We do need shared places where we can collaborate. Companies do need escape hatches that they can build on and know that their destiny is their own. And I know they also love to have passionate, involved people, and companies like Cosmonic that are there that support and help to build great picks and shovels to help them adopt, embrace, and scale and move a lot faster to help out innovate their competitors.
This is just great. The world needs more people like you and Bailey in it. I mean, I'm serious. Yeah.
All right. A little more.
Great work here.
Yeah, no, it is great work. So I want to close this out because we are getting to the top of the hour. I want to close it out with a question that goes towards developers, and it's I guess it's kind of a question for you, Bailey. And then we're going to go into our short shameless plug, and we're going to close the episode out. But Bailey, so if you were to kind of boil this down for developers, if you were to kind of point developers or give developers one bit of advice in terms of them either coming to WebAssembly or developers who are already on WebAssembly and how they can boost their skill set or help them in any way become better WebAssembly developers, what would be that bit of advice that you would give them?
I would say join the community. We would love to have you. We have so many amazing folks that would make awesome mentors, and we need you. We need more hands-on keyboards working together. And so 2 awesome communities to be a part of is in CNCF WASM Cloud and in the Bytecode Alliance.
Excellent. And I'm going to need to possibly ping you later with an email to see if you could give me a list of all of the different resources we've talked about in this episode. We're going to have to go back and listen. I'm looking at Gabe here. We're going to go back and listen and get all of those down because, you've mentioned so many cool places that developers should go visit and check out and start reading on. Okay. So let's go into a quick shameless plug. We'll start with you, Liam. Is there anything that you'd like to plug, send people, call to action, whatever you want to call it?
Yeah, sure. I mean, I have to follow Bailey's selfless example and plug some of the community things first here. In just 2 short weeks, we will be live streaming the Plumbers Summit, which will let folks sort of look over the core developer shoulder while they work on the roadmap. We'll be live streaming that right out of Raleigh. Then we'll be followed by WASM.io in Barcelona. And then KubeCon EU, where we've got a great program already listed for WASM Day. So I hope you'll catch folks there. And then for everyone on the call, stop by cosmonic.com and just click launch now. Give us some feedback. We'd love to have it. You can join our Discord, or if you'd like to participate in the WASM Cloud community, it's just slack.wasmcloud.com. And if you're an enterprise or platform engineer, we do have just a couple of slots left for a few companies that are interested in trying our new enterprise offering that we are exploring now. So feel free to just DM us or find us on social media or reach out. I'm just Liam at Cosmonic or Hectaman on Twitter, LinkedIn, all the places. I could keep going, but you can find us on YouTube, social media, all the other places, or at a WebAssembly conference near you.
We'll make sure all of those links, thank you, Liam, by the way, we'll make sure all those links show up in the description, of course. Yeah, thank you. And for you, Bailey.
Yeah, I definitely am. I'm going to reiterate about joining our community and WASM Cloud and in the Bytecode Alliance. We really would love your contributions, your feedback, your use case, your user story. If you're interested in doing embedded work, we're looking to spin up a new special interest group within the Bytecode Alliance for a focus on a lot of these folks that have these tight hardware constraints. And so I really want to learn from anybody that's out there. And I guess one other thing I want to plug is my favorite charity that's near me. It's called Code the Dream, and it's based out of Durham, North Carolina. And it helps teach kids how to code so that they can get the best start in life.
Love it. Love it. And last but
Oh, I think we just lost Robert there.
No.
I hope he was going to hand that over to me. So, gosh, this has been a great episode. We talked about so many things, and I still have half of my questions that we didn't have time to get to. So, join the Cosmonic community. I'm going to go find your Discord. I also encourage anybody who's doing any kind of WebAssembly to let us know in our Discord. That's discord.gg/armsoftwaredev. You can find us there. You two, of course, are both invited to come hang out there and talk to ARM developers about running their code on WebAssembly as well.
Excellent. Awesome. Thank you so much. Mike, should I close this out now? Are we ready? Bailey, Liam, all good? Okay,
That's
cool.
great time.
Well, yeah, on behalf of, Michael, myself, on behalf of ARM, Bailey, Liam, thank you so much for joining us. We appreciate your time. Everyone out in the community, everyone watching either live this entire hour or on demand, you could have spent it doing so many other things, and you spent it with us, and we love you for that. We appreciate it very much. If you enjoyed the episode, please make sure to like it, subscribe to the ARM Software Developers YouTube channel, and we will see you next week and every Thursday at 5 p.m. UTC with amazing individuals like these talking about all the cool stuff that's happening in and around the ARM developer ecosystem. So we look forward to seeing you there. Y'all have a wonderful week, and we will see you next week. Take care. Bye, everyone. Thank you.
Bye, everyone.